Hello and welcome to Grand Canyon University's Canyon Professional Development. You are here for a course called Choose Your STEM Tools. And I'd like to start with a quote by Jeff Duntman. A good tool improves the way you work. A great tool improves the way you think. I want you to think about this quote as we set our stage for learning regarding the tools we choose for our STEM classrooms. Could be a makerspace. It could be a place inside of your classroom where you're keeping STEM materials. And it could be a school-wide initiative to bring STEM to your site. I'm your host, and I want to introduce myself. My name is Corey Araza, and I'm the Senior Project Manager K-12 STEM Outreach here at Grand Canyon University. Our goal, or my goal, is to support K-12 teachers on their journey in STEM. I have background in STEM, computer systems, ESL, Spanish, tech integration, and makerspace education. I've created more than one makerspace in a busy high school environment. And you can follow me on social at GCU K-12 Ed or at Ciaraza. And don't forget, our YouTube channel is chock full of information at bit.ly/K12 EdDev. Feel free to use your telephone and connect right here in this platform that you resonate with the most. Let's get right into choosing our STEM tools. Our course objectives are to review research behind integrating STEM into your daily teaching practice. We're also going to look at active learning to identify STEM tools that encourage active learning, and then be able to choose the STEM tools that align with inquiry learning and relate to your teaching level or content area. When we're finished today, we will have a roadmap where you can go out and purchase the STEM tools that you think you will need for your STEM classroom to come alive with active and inquiry learning. So let's go through this course map. When we talk about tools, how the tools that you choose depend on your STEM interests. So I'm really going to paint a picture, draw a roadmap for you to think about what are your passions, your desires, your interests when it comes to STEM. You may be a math teacher, so clearly you say, oh, I really love the math tools. Great. Maybe it's a Sudoku puzzle, or maybe it is a cipher wheel to get kids interested into that math area. Perhaps it's some sort of subscription to simulation software. Perhaps your excitement in passion in STEM has to do with building and construction materials. Maybe you loved Legos as a kid and engineering is the way you're going. Or perhaps you love to decorate or interior design in your own home. And maybe architecture is that interesting STEM tool to you. And I've got tools in all areas, interdisciplinary STEM. That's what we have on dock for you today. So let's look at this course map. We're going to plan, look at the research in STEM education, which tools show active learning, which tools inspire inquiry learning. With this, we have to identify your goal. So take inventory of the tools that you already have. We're going to go through this by looking at the picture, the big picture. Identify tools appropriate for smaller tasks that lead to that big picture. So once you set your goal, perhaps if you're really going to focus on engineering this year, that might be your big picture item. And then what are the smaller tasks that you need to purchase tools to get you to that bigger picture? Maybe it's a STEM competition. Maybe it's a robotics competition. Now we're going to look at that passion. Remember, when you bring your passion, your students will follow. Your students, they just get excited about the inspiration that you bring them. So let's explore the STEM tools that ignite your interests, and your students will follow the lead. Finally, and probably most importantly, STEM tools inspire problem solving. So we're going to problem solve. Real world problems equal real world solutions. So discover what tools bring STEM together to solve real problems in your grade or your content area. Let's get started. When it comes to STEM education research, I'd like to start with STEM education science and engineering indicators in 2022. Students who have positive perceptions of their mathematics and science abilities in high school are more inclined to declare a post-secondary STEM major. So the more they practice, the more they feel confident, the more they will go into STEM. We want to start with that first place on our roadmap, plan. How do we plan to gather tools that are research based. Well, let's see what research based STEM tools promote. They promote interdisciplinary collaboration through STEM. And I put the periods in here because we have science, technology, engineering, and math, and we want to use them all together, not separately like separate silos. So the more you can collaborate, if you're a math teacher, if you're collaborating with your science teacher, excellent. Even go one step further, collaborate with the Spanish teacher or collaborate with the English language arts teacher to bring STEM through literature. Always interdisciplinary, but those four subject matters, using technology to solve problems, using engineering to have that application base in math. Secondly, STEM integrative practices equal problem solving. You cannot solve a problem in a silo. You have to have collaboration and you also have to have the different disciplines. You might need a spreadsheet in order to bring the mathematical concept alive. Integrative practices. Next, teacher self-efficacy. That means you, as the teacher, you have to feel confident and interested in the STEM tool that you're bringing to the table. That doesn't mean you have to know all about it, how to use it. Your students will surprise you in that way, but you do need to feel comfortable and confident in facilitating STEM instruction. And finally, perseverance through challenge. Projects are attainable and cost effective. So when you start to look at the STEM tools that you are going to purchase, remember that the challenge is excellent, but we want to get to that zone of proximal development. We can't go too challenging, and we certainly don't want to go not challenging enough. So think about the projects that you're going to create, that bigger goal in mind. And then remember that you want to keep them attainable and cost effective, not only for you in your classroom, but for students and parents in the future. For example, if they go out into a STEM competition. So the question I would have for you is, where are you in your STEM stage? Are you at stage one, where you've got simple and engaging construction for fun? So I have a couple of pictures of straw rockets. This is a great way to get students into just the excitement and engagement in STEM. I have a straw rocket there. I also have a marshmallow catapult. So you can make catapults, you can make rockets with just the basics of paper, straw, and tape. And those are going to be our number one STEM tools, just those basic office supplies. Maybe you're at stage two, where you're really using engineering design process to focus those STEM concepts in designing, planning, and building. For example, bringing elements out of copper, kind of a recycling project there. We've got Sphero Golf and Snap Circuits. Those are ideas of different robotics or coding activities, circuitry activities that inspire and spark interest in the engineering design process and in those more challenging mathematical or science concepts. And then finally, maybe you're at stage number three, and this is my favorite stage. And you don't have to necessarily go in order. You can jump right into stage number three, where you can ask your students, hey, let's go compete in a STEM competition. They may or may not be ready, but that's okay, because it's about the process, not the product. It's about the process. It's about try, fail, repeat, keep going. Inquiry learning is about trying and trying again. So that might be a robotics competition. Now, this one is kind of a more complicated robot, or maybe it's the disaster relief shelter, or maybe it is an Arduino-based robot competition. There are so many competitions out there, and there are, again, real world problems to solve. And I know that your students are ready to solve them. In order to solve real world problems, let's look at the big picture. So what is your school classroom environment want to accomplish? What do you want to accomplish as an educator? What is your big picture? In order to get to the big picture, we want to use the engineering design process. Now, this is a part of the science and engineering practices. And so it's very important that we think about this process not only in the science classroom, but also in the math classroom, in the technology classroom, in the engineering classroom, and beyond, because I think we can solve any problem utilizing the engineering design process. So this is one example of the engineering design process where we always start with stakeholder input, meaning who are our clients? In the technological realm, where I used to be in the technological industry space, We had project management. It was a must do. We had to know what is it that the client wants, what problem are they looking to solve, and what kind of computer code can we use to solve that problem and make it more efficient for our end user. So our stakeholder would be our end user in the technological space. But our stakeholder in a classroom or community environment in a school, we have to think about, what do students need? What do parents need? What do board members need? What do teachers need? How are administrators involved in supporting the needs? So again, stakeholder input is at the center of the engineering design process. And it always starts with, yep, you guessed it, problem solving. We are looking at a problem. We have to identify, what is that problem? What is the project that we want to complete, or what is the problem that we're trying to solve? This could be something like, we don't have enough seating in our cafeteria for lunch, or it could be something like, we have a hole in the fence going from the playground over into the neighboring community area. Do we need to fix that problem? So let's identify the problem, and it's always best to do that alongside your students. Then we want to imagine solutions. How might we solve that problem? And this, folks, is where we get into collaboration, brainstorming. I have all kinds of resources for you in our links and our handouts, where you can look at, what does brainstorming really mean, and how many people can we get into the mix to help us come up with creative ideas to solve the problem. And I'll tell you, the wackier the idea, the better. We go quantity over quality for brainstorming, because we're imagining those solutions. Once we find a solution that is viable, we're going to define the specifications. And that goes back to the stakeholder input. What does the client say? How much money do we have to spend? Right now, you have to define your specifications for your own STEM tools list. What does your budget look like? What do you already have on hand? What might you be able to repurpose? Defining specifications. That means that we do have to solve within some constraints. Once we define our specifications, we start to plan, design, and build whatever it is to solve the problem, or whatever project we're making. Earlier, you saw marshmallow catapult. We still have to plan, design, and build that marshmallow catapult, even if we have popsicle sticks and straws as our materials. Once we design it, we're going to test it. We're going to see if that catapult actually works. And sometimes it won't. In fact, most times it won't. We don't want it to work on the first try. We want to continue to try and fail and try again. So we test and revise. This station right here is really, it goes back and forth a lot. We plan, design, and build, and then we go back and test and revise. We plan, design, and build, and then we test and revise. When we're finished, or at least finished for now, we want to share our design, our product. Once we share it, then we will get feedback, right? The stakeholder will come back and say, yeah, I do like that, but could it be a little more this or a little less that? And that's the important piece of sharing. So our STEM showcase nights are really important, so that our parents can see our students succeeding, and they can also add some input on what they could do to improve their design. Because as we all know, there are many more versions than just the first, right? I think we're on the Apple iPhone version 13 or 14 by now. So consistently getting better and better as we go around this circle. And finally, in that reflection process, after we share, we reflect, then we go ahead and continue on with version number, insert the next version here. That reflection sends us right back to the top, or the circle of the engineering design process, because the reflection includes, how are we going to make this better and rebrand it? Now, I'm going to add another piece to the engineering design process as far as Grand Canyon University is concerned, because we are all different and we personalize at different levels.
Another way to look at the engineering design process is to really create it yourselves. So, in other words, taking your classroom experience, taking your community, and your motto, or what you stand for lack of a better term, your why. We start with our why, or we finish with our why in every presentation that we do, so that we remember what stands in the center of our engineering design process. Another way to look at the engineering design process is to truly create a poster with your own version. For example, the idea or the problem that you have to solve, if you think about it from your stakeholder input and you define what your stakeholders look like, what your focus or your why is, you'll start to look at the big picture. And that picture allows us to see the more important nuances of the engineering design process. Looking at this big picture allows us to take the smaller pieces and parts to look from part to whole. And this really also is a way of systems thinking. If we take our idea, we want to solve a problem in service of others. In our Lopes lab, for example, we are able to plan it. So we start to brainstorm and think about what it is, to imagine those solutions as we talked about earlier. And then we move over into designing whatever that solution is to the problem that maybe our stakeholder, our client has. And then we'll make it, whatever that happens to be. For example, at GCU, if you make anything as a student in our engineering machine workshops, you get to own 100% of the intellectual property as you make it, test it, continue that process, right? Making, revising, testing, revising, and then share it with the community. So once you share it with the community, the neat part about what we do at our engineering design process in our Lopes lab is then we want to scale it. We have something called Canyon Ventures, company space where students can create something. They can solve a problem in service of others. They can design it, make it, test it, share it, and then scale it with the help of our Canyon Ventures. We have angel investor programs, and we also have other investors, including Shark Tank has come on and awarded some of our students. I'm showing you this poster because I want you to think about your own classroom, your own school. What is your why? What makes your school unique? What belongs in your stakeholder center, right? So we had our stakeholder higher purpose there. You might have, the community of which you serve. So think about what that is and start to consider what kind of poster would I design for my classroom? What would I brainstorm for my classroom? And if you have the opportunity to bring your students into this, I highly recommend it. They are fantastic at designing your engineering design process as it relates to your school, your students, and your community. So that brings me to our first activity, our first handout. This is called the engineering design process, and you'll find it in your handouts materials that can come with the course. And you are going to brainstorm what the engineering design process looks like in your classroom, school, or community. This is a great process allowing you to start to think deeply about that big picture. So once you've opened up your handout, you'll be able to sketch out an engineering design process poster for your classroom. I've got lots of examples that you can look at, including the example that's here below. And you want to add elements from your classroom, your school, your community, your stakeholders into the wording and the design of your poster. Much like what you see in our poster here, some of these very key words that we've used to indicate what we believe as a part of our engineering design process here at Grand Canyon University. See handout 1 with resources. Hopefully you've had a moment to take the time to think about the big picture. Thinking about that big picture allows us to know what our larger goal is so that we can move back into the parts. This course is called Choose Your STEM Tools, and this, folks, is your design and build tools map. I want to let you know that as we create as we purchase our STEM tools, we need to create that big picture for our classroom. So just thinking about the design and the build piece of that engineering design process, planning, designing, and making. In the other engineering design process, we have imagine solutions, define our specifications, planning and building, testing, revising. So all of these are different examples. We're ready to look at that design and build phase. So as I had said before, you can do STEM very inexpensively. Again, when we look at the research, it's important that we have something that is attainable. And when we talk about a project that's attainable and cost effective, these are projects that our students can really wrap their heads around. And not just our students, but our parents, our community. So on hand in your maker space in your classroom, or maybe your Genius Hour location, here are the things that I recommend that you purchase or put on your list. Making sure we have butcher paper, which many schools already have that. Post-it notes are fantastic for brainstorming, which we talked about the importance of brainstorming. Classroom set of mini whiteboards. This is a great idea for all the students to be able to collaborate together. And anything you see that is underlined, that is a link that you can go to directly from the slideshow and move right into a link. Generally speaking, I've used Amazon links, but I've also used links from different organizations. So make sure you see you have whiteboard markers and gloves on hand. Those can be a little expensive as far as the budget for your regular school supplies. We have a great teacher tip in our YouTube channel all about a glove that you can purchase at Target, and you just cut the fingers off and boom, the kids have a glove that they can use in their whiteboards. It's a fantastic teacher tip. Go check that out at our YouTube channel. Remember that you're going to need web access. So if you're going to do some coding and robotics, you're definitely going to need web access. So that could look like Google Chromebooks. It might look like iPads, depending on the type of classroom you have. If you don't have web access, or if you don't have very many tablets or Chromebooks, computers that you can use, that might be something that you want to invest in first, because that's going to be very important as you move down the road. So in our building or prototyping area, definitely cardboard. I say cardboard and tape. I think mostly the K-5 area is like masking tape. You might want to be cautious about how much tape students use. I understand they just love that at the younger grade levels. At the older grade levels, cardboard, duct tape, index cards, straws, cotton balls, pipe cleaners, old compact discs. Those are great for making cipher wheels. So there are so many things you can do. Not only are they good for making cipher wheels, but they're also good for making wheels on cars. And that's something that you can create and design, let's say, a mode of transportation. So all of these types of items, office supplies, scissors and paper clips, there's some really cool scissors that cut cardboard really well. You can check those types of things out as you go into your shopping spree. But making sure that you know so much of this doesn't cost a thing. Paper towel rolls, toilet paper rolls, Play-Doh, maybe that costs a little bit, but cups, ping pong balls, cotton balls, very, very inexpensive. But to have some of these supplies on hand so that students can create with recyclable materials. And that's what we need to do, folks, is reduce, reuse, recycle. Once we move over into the this side of our design and build STEM tools list, I recommend bins for storage. So they definitely have to be organized and make sure that your students stay organized. So don't forget to teach the behavior of how to be in a STEM tools classroom. Things have places and belong in their place. So make sure that we teach that behavior of putting things back where they go. Also, it's just hard to have a maker space or a STEM space without Legos or Kiva planks. Zoob is also a great different kind of connector. They have really neat joints, connects, magnetiles. I've allowed you to just have a look at all of these different types of building materials and deciding what your budget looks like. As I said, the mini whiteboards. And then so many people ask me, what about 3D printing? And I will tell you that if you are going to design and build, as you have a construction thought process around your makerspace or around your STEM classroom, I highly recommend a 3D printer. But I want you to know that if you don't have someone dedicated, and this can be a student or even a classroom of students, dedicated to, making sure the prints are running, making sure that you have a repair person on hand, making sure that they can train appropriately. That filament, we got to make sure that it cools down appropriately when the machine is off. Otherwise, it can be a bit of a nightmare. So really think clearly about 3D printing prior to buying a 3D printer. It might be in like a second stage STEM area where you are. If you do want to buy a 3D printer, my favorite is the MakerBot Replicator. It's very expensive, but it's worth the money in the long run. The FlashForge Creator Pro is an excellent printer as well, and I understand that's even better for like the younger grade levels. K8, less maintenance. MakerBot is often at that high school and college level. And then there's this great site, Learn by Layers, and those are lessons for 3D printing. So this entire site is just dedicated to 3D printing. So check that out. Tinkercad, if you haven't heard of Tinkercad, that is kind of the thinking in 3D that needs to happen prior to printing in 3D. So that is your software. It's made by Autodesk. It's free. The Autodesk and SolidWorks are kind of competing companies in this space of 3D software. And I highly recommend that you start with Tinkercad to get your students to really think in 3D. And then once they build their first print, turn that into an STL file, as we call it, and print it on the 3D printer, they just get excited. I've got some other materials here for you to design and build in coding and robotics, AR, VR. Sphero robots are fantastic. The Makeys are also a lot of fun, where you can play with coding and circuit design utilizing just household materials, and they're very inexpensive. Google Cardboard, AR, VR utilizing smartphones are exciting. Merge Cubes bring AR and VR to life, augmented reality, virtual reality. The Dash robot or the iRobot Root, the Arduino-based robots. And then if you want to really get into robotics, Vex and FIRST are your two top robotics leagues. So check those two out as well. The other design and build, more on the inquiry-based side with math, science, and inquiry, think about tools like microscopes, interactive simulations. These are free pieces of software. Learning genetics or biodigital. The Straw Rocket Launcher, that's actually a fantastic rocket launcher that is very durable. So that's why it costs. You can make straw rockets easily enough, but if you really want to get into aerospace, think about the Pittsco Straw Rocket Launcher. We have the NASA Global Climate Change website, cipher wheels, and graphing calculators for math. I have gone through a giant list here for designing and building. I know there is something on this list that might resonate with you. Take some time and look at what is interesting to you. All of them are categorized, and you're going to look at the more important nuances of making categories for your STEM outcome. Kind of overwhelming list, but it's here for you so that you can come back to it, stop, start, and really do some research on what you would like to purchase for your design and build phase of the engineering design process. The next thing that we want to talk about, I think, is so important. It's really what makes us teachers unique, and that is our passion, our personal passion for our passion projects. Sometimes our genius hour is called the passion project. And the whole idea is based in, what do you find interesting? What problems do you want to solve in this world? And how do you want to bring that into your classroom? So I think visuals are the best way to think about passion when we are expressing our own desires. And I mean that by you, the teacher, you, the educator. What are you most interested in? Well, obviously, if you're a science teacher, that's probably where your interest lies. But there are many aspects of science. Is it in the bioscience or the biology area? Is it more in the engineering area, architecture? Perhaps it's mathematics, technology. These ideas are really what we'd like to see just drive your classroom. So again, thinking of the big picture and then coming to passion. What is the passion that you have to solve problems in our world? Some teachers I meet are phenomenal gardeners, and that's a great place to start with STEM. Some people that I meet in the teaching world just want to help kids solve problems with a logical spatial structure. And that sometimes just has to do with engineering and organizing the bins in your makerspace. So really think about your own passion and think about where you want to bring which tools into your classroom. Maybe it's cooking. Maybe it's sewing, maybe it's scrapbooking, maybe it's movie making. When I was in the classroom, I loved to make movies, and it just made sense to me. I felt like it was digital scrapbooking. And so I purchased several pieces of software, lighting, podcasting materials so that my students could really bring media to life. That's something that I was passionate about. What are you passionate about? So let's think about STEM tools, and I've made for you another list to consider as you think about your passion. Now, number one, you want to bring your passion into your classroom, but number two, you want to show off your makerspace or your STEM students at a showcase. So without a STEM showcase, your community doesn't know what you're doing. So this is the part that really focuses on share, reflecting, and scaling. Now, scaling might not be where you are in your classroom. You might not have businesses started in your classroom, but I guarantee you it's happened. There's a in our handouts and resources, you'll see a story about a young man who was in elementary school. He has a booming 3D print business. So don't put it past your students to impress you and try to scale their idea. So you'll see over on the left-hand side, the same list of basic STEM supplies, but I've changed things over here on the right-hand side. Like example, do you want to buy a sewing machine and material and measuring tools to accompany your passion for sewing? That's an absolutely wonderful idea. We have things called wearables now, where we're sewing LED lights and coding them along with the choreography of a dance. That's big time in technical theater. So it's a great idea to bring that passion into your classroom. Maybe there's software that will help you drive your passion. Is it SketchUp, architectural software? Is it Adobe Premiere Pro to make movies? Is it Final Cut Pro to make movies on that grander scale? So think about what kind of software would help to really inspire your passion. Now, moving into sharing and reflection in that engineering design process, here is where we bring in that STEM showcase. And folks, you need tools to be able to show off your STEM showcases or your STEM students' projects that they have created. You want to drum up excitement for STEM at your school, then you definitely want to have a showcase. And my guess is that you already have a parent-teacher conference night. Why not have a showcase while your parents are waiting to talk to teachers? A showcase of problems, solutions and perseverance and challenges that your students have gone through. Maybe they've made those marshmallow catapults and they want to show those off. Maybe they have created a robot. Maybe they have a robotics competition video that they want to show off. So think about what you need at that showcase. You might need display tables, furniture, maybe some video staging equipment and lighting, microphones, a portable speaker or podcasting materials, maybe a projection system. All of those things cost money. And yes, you too can create your STEM showcase, STEM tools area in your classroom. Hopefully this has given you a little bit more food for thought in regards to your passion and what makes the passion speak loudly to your students. Now, a lot of teachers will ask me, okay, my goodness, Corey, this is so much. How do I organize it? How do I buy all of this? It's so expensive. It's such an investment for all of my students. And my statement to you is, yes, it is an investment. However, I will also tell you, having just a few materials at each station makes a lot of sense. So maybe buy a couple of Makey Makeys and a couple of Dash robots and a couple of pieces of coding software or maybe the architectural software. And then you have students can go around to different stations. So planning station, building station, designing station, knowing that you have different items in different areas allows for the interdisciplinary nature of STEM. In the real world, we have project management where one person is working on something, a part of the whole, and another person is working on a part of the whole. And then when we get together, we bring those things together and we solve problems. And that is what we want to do, is problem solve. This is our fourth P area where we want to look at that roadmap again and how do we create STEM tools that solve problems, not just create, but purchase, right? We also want to purchase these STEM tools that help us to problem solve. What does that look like? Well, the sky's the limit. We did have a metal shop in our high school, and so we were able to create these letters, for example, for our dream board in different mediums. So one was metal, one was wood, one was ceramic, and we had this concept of this dream board, this concept of creating a dream board so students could think about their bigger picture. What do they want to create? What do they want to make? This here is Joey, who created a homework help app for the entire high school. So he's not just creating it for a project in class, but he's creating the app and it's downloadable for the entire high school so that it's personalized and it feels like something more than just a project for school. We also built wooden planters in the wood shop with physics and math courses. And then you can see they're also, decorated, growing salsa or herbs for salsa with our culinary arts program. So if you can see that physics, math, wood shop, culinary arts, all of these things came together to solve a problem for our community. Then we sold the salsa at a parent teacher night or STEM showcase night. And it comes full circles, that engineering design process, solving problems in service of others. Luis made an air-cooled backpack as his passion project. Well, he had to learn a lot of physics concepts to figure out how he could do that and couple that up with engineering in order to create that air-cooled backpack. So think about some of these areas in your school and your classroom that inspire you. And finally, let's look at the STEM tools for problem solving. Now, very similar to what you've seen before. I'm not changing this first slide at all. All of these items are necessary for problem solving and they're not expensive. You can also bring over this concept of building prototyping for problem solving in your community. So what does that look like in your community? Is it a STEM garden? Is there something that, can you do the same thing by, growing basil and cilantro on your campus and creating salsa jars and selling those for your community? Could it be a 3D print business? Can you create a business where your students would get hired on your campus? We have inquiry tools for problem solving, and these tools are really very specific for, say, biology, chemistry, from beakers to graduated cylinders to pipettes and droppers. These are also tools that solve problems. Microbiology style project, eliciting that inquiry. How are we going to solve the next disease problems? How can we help our medical professionals solve problems, the problems that COVID-19 has brought into our world? Think about what sorts of materials and tools you'll need to get started. And we've listed here a getting started list for you to go out and find out what inquiry tools you might need for your classroom. Finally, that share, reflect, and scale, that STEM showcases, I left that in to make sure that once you decide what tools you're going to buy for problem solving specifically, you gotta show it off. Show off your students' talents. They will not disappoint you. And I really look forward to seeing what sorts of showcasing STEM tools you'll purchase as a result of wanting to show off their problem solving skills. Well, we've come to our final handout of the class, and this handout will get you started. So this is the Create Your STEM Tool list. You are going to create a list of STEM tools here, utilizing the engineering design process sketch that you did in our activity number 1, our first handout. Now that you've seen all the lists of STEM tools inspired by planning, keeping that big picture in mind, passions and problem solving in your community, you are going to create 3 categories for interdisciplinary STEM in your classroom and choose materials for each category. Here are a few example categories. Okay, we could have a plan and design category. Maybe we just purchase office supplies there and we write down our list of office supplies that we're going to buy, or collect or gather. You don't necessarily have to buy everything. Category number 2, maybe build and prototype. Legos, construction materials. I left a lot of information there for you to choose from, the types of building materials that you could look into. Also, category number 3, maybe that's the share with community category, projectors, podcasting equipment, maybe tables. So those categories, that's one idea. Here's another idea for categories. Maybe construction materials is one category, and you're going to add Legos, prototyping tools to that category. Maybe coding and robotics is your second category, and you purchase Makey's or robots or Google Goggles for that one. Category 3, biology materials. Okay, so I'm going to have 3 areas or stations in my STEM classroom, and one's going to be sort of marked construction, the other coding and robotics, and the other biology. Those are 3 different areas of science, technology, STEM areas that make sense for your students. And remember, that web access, the computing devices that you have in your classroom, well, those are kind of seamlessly integrated into your categories. So look at those 3 categories here, the gardening supplies, microscopes. I don't know what it is that you're passionate about, but I do know that that passion can definitely inspire your students to follow their passions. It has been a whirlwind of a class, our Choose Your STEM Tools class, and I certainly hope that you were able to take away at least 1 to 2 items that you hadn't thought about before. Maybe that's the engineering design process, personalized poster that you've made for your classes. Maybe that's thinking about your own passion and really deciding, I'm going to start there with my passion, because if I'm passionate about something, I know my students will follow. And maybe it's just a list of materials that you can just grab hold of and say, yep, that's what I want to purchase. And you can send that right over to your Amazon wish list and get started. Either way, I hope you were able to take something away from our Choose Your STEM Tools course. We start and finish with our why. We are here to empower, educate, and inspire our communities so they take action to fulfill their purpose and serve others. I hope that you had an opportunity to develop your why within your engineering design process, your plan, your problem solving ability, your passion and purpose in all of your STEM tool journey. Thank you for evaluating this Canyon Professional Development course, and we appreciate your time. We have a free collection of professional development at our YouTube channel at bit.ly/K12eddev. And we'd love for you to go on over there and subscribe, and you'll see a lot of STEM videos there to help you out, especially when it comes to choosing STEM tools. We are at canyonpd.com. We are on demand, low cost, and individualized. So hopefully you can find another class in this course offering catalog that will inspire you in STEM and other areas of the classroom. And again, don't forget to connect with us on social media. We are constantly updating our information on social media to share with you different opportunities to come in person for professional development, or even more courses online, as well as lots of events. Students here at GCU wanting to help and outreach in any way they can in your classroom. Finally, I have a list of references, so please don't hesitate to check out all of our references and important resources. So there are resources here, and there are 3 handouts that go with this course that include all of the resources that you will need to choose your STEM tools. Thank you so much. Until next time.